Well, 5-1 was pretty short, so we'll do another, 5-2. Here we are to simplify each expression, write results with positive exponents. Okay, we'll keep that in mind. All right, but first we're going to find the degree of the following polynomials. Now remember, the rule is we only count exponents on the variable. And if there are multiple variables, we just add the exponents within the term. And the largest term, degree, that would be the degree of the whole expression. So let's follow some of these. So this one is sort of easy. There's only the 1 there, so this is 3. Now when there isn't a 1 written, it is assumed to be there, so that's to the first degree. All right, find the degree of each of the following polynomials and determine whether it is a monomial of 1 term, binomial of 2 terms, trinomial of 3 terms, or none of these. This is 2 terms, so it's a binomial, and the degree is 4. This is 3 terms, again separated by pluses and minuses, and the degree is 3. Trinomial. I like these worksheets when there's enough room to write things out, and I don't have to make charts and everything like I did when I did the lessons on the whiteboard. So here we have a polynomial. Its degree is 3. And how many terms? There are 4 terms. Terms are separated by minuses and pluses. So here's our first term. Now we can divide that into a variable part, which is x to the 3rd, and a numerical coefficient, which is 7. That's the part that's in front of the variable. And the degree of that, we said, was 3. Now, for the one that has 2, the numerical coefficient is -2, and the term is -2 x squared, and its degree is 2. Now the term that has a degree of 1 is this one, that we don't write the 1, and its term is just x, but its numerical coefficient, even though we don't write it, is a 1, and it's to the first degree. And here our last term is this. Its numerical coefficient is that. That's often referred to as a constant. And when there is no variable, its degree is 0. Now here we're asked to do function, and we said a good way to do that is put it in a t-chart. This is going to be p of x, and the ones we are to do is a 1 there, and here it's a -2. So if you put a 1 in there, this is going to be a 5 plus 1 plus 1. Our output is 7. And here if you put a -2 there, that's going to be 5 times. A -2 squared becomes a +4 minus 2 plus 1. So this is 21 minus 2. This will be a 19. And the same for this one. A little t-chart. This is just giving you a way to do it. And this will be t here. So t is 2, t is 3. This is the formula for a falling body. I think we did something like that. So if we square 2, we get a 4. And this becomes a 0, because that's a negative 64 plus 64. Now when we square 3 and get a 9, this becomes a negative 16 times 9, then a plus 64 gives us a negative 80 altogether. And we'll move on. Now, we had said like terms, by definition, have pretty much exactly the same variable. So if we identify something as like terms, then we just add the numerical coefficients, which gives us a 17x here. Now here we have two like terms, keeping in mind there's a 1 in front of this, so this will be a plus, which we don't write, 6x squared plus 7. I got carried away. We don't write the plus. Now here we have this as a like term, and then these as like terms. So this and this give me a 16 t squared, and this gives me a minus 4 t. Again, the variables never change when we are adding or subtracting like terms, combining like terms. Now in number 10, what I did was to kind of group the like terms together. So these are like terms. So this is going to end up being 2x to the 4th. And then in my next set I have fractions. So I have to multiply this by a 2 and this by a 2. So now I have 2 sixths plus 1 sixth is 3 sixths, which is 1/2. X to the 3rd. And then we have this one. Now, when we have parentheses, and there's a plus between them, we can just take the parentheses away and add our like terms. So this is 4y minus 2. Now, when we have a negative in front of a parenthesis, here there's nothing in front of the parenthesis, so we just take the parenthesis away here. But now, when we take this parenthesis away, we have to change all these signs. This is going to become a negative, this will become a plus, and this one becomes a plus. That's the rule of subtraction. Remove the parenthesis and change the signs, and then combine like terms. And it's often signed numbers. So here our like term is this and this, which then becomes 5x squared. And then we have x's here. This will become a negative 8x. And then we have just these last two, this one and this one, which gives me a plus 3. And I probably should check my answers. And that looks good. Okay, now the next few are more tedious, so I'll pause the tape and do them and show you the techniques. Now over here, what I did for number 12 is that this was negative, so I had to change these signs. Maybe I did that one already. Okay, let me do number 13. Here this was a negative in front of the parentheses, so I changed this sign, change that, and then just combine like terms. Here the only one I had to change was the last set. Change this to negative, change this to negative, change this to positive, and group like terms. Now here when I say something like this, just remove the parentheses because we're just adding, and watch your signs. Here, again, we're adding this and this. This is just like a plus. Now, here's where it gets tricky in number 17. Because what are they saying to do to this? And the answer is subtract. So think of a big negative sign here in front of that parenthesis. What do? Well, you change this sign, change this sign, and change this sign, and now just add them together. You don't have to put this one after that. Just change these signs and add like terms. Now for number 18, the same technique. It says subtract. So change this sign, and these are okay. You're just adding up like terms. And here again, subtract, change this sign, change this sign, change this sign, and add like terms. Again, we're changing this one and changing this one. Now, a technique that I didn't see here, a place where I could illustrate it, is instead of doing these horizontally, you may want to line up the like terms vertically. So let's see what we have here. We have a negative 2x and a negative 1. Here we have a positive x. We could put a 1 in front, and a negative 1. And here we have a positive 5x and a positive 7. Now what I've done is I've made like term columns, vertical columns, that I really stressed in the lesson for doing these. So this is going to be a positive 6, and this is a negative 2, so this gives us a 4x. This is a 7, minus 2 is 5. So I don't know if this little technique will be helpful, but later when it gets complicated, using this vertical method, I think helps to organize and lead you toward the right answer. And this will conclude this one. Went a little longer. We went almost 13 minutes here.